A rock is thrown with a speed of 10 meters per second and an angle of 30 degrees from the ground. Determine the time it takes to hit the ground, how far from the starting point does the rock land, and what is the max height that the rock reaches above the ground. Again, we're going to start by setting our reference frame at the rock. And then what we're going to do is we're going to write our knowns and what we're trying to find. So our knowns is we know that the initial x position is 0, initial y position is 0, and we know that our final y is 0. These are all meters. We need to now decompose our vector into our x and y components. To do that, we have Vx naught equals v cosine theta, which is 10 cos 30, which equals 8.66 meters per second. And then we do the same for y, but we have v sine theta, and it's going to be 10 sine 30, which is 5 meters per second. So what we're going to do is we're going to start, just like we did before, we're going to use our second y equation to figure out the time. If we do that, we have y equals y naught plus vy naught t minus 4.9 t squared, where we know y and y naught are 0, so we get v y naught t equals 4.9 t squared. T will cancel, and we can find t as v y naught divided by 4.9, which is 5 divided by 4.9, which equals 1.02 seconds. Then we can find the x displacement by using the x equation for the kinematics, which is x equals our initial position in the x plus our initial velocity in the x times time. We know that this is 0, so we can say that this is just equal to v x naught t, which we know is 8.66 times the time we just found, which is 1.02, and we get a displacement of 8.84 meters. And now if we want to find the max height, what we're going to do is we could do this two different ways, but we're going to do it the simplest way, which we're going to use a third equation in the y direction, which is our final velocity in the y squared equals our initial y squared minus 19.6 change in y. And we're going to have to use the fact that at the very top, we know that the y velocity is equal to 0. So we know that this is equal to 0. So then we can say our initial velocity in the y squared is equal to 19.6 change in y. And we can solve for change in y, which change in y is vy naught squared over 19.6, which is 5 squared over 19.6, which equals 1.28 meters.